Yeah. Okay. So we are here up for to the lineup. So it is like we're starting with first look and then followed by essentials, and it is actually OpenStack essentials and OpenStack architecture and what all the services offered by OpenStack, and finally the dashboard. So we just begin with the first look. Over at the first look, it is like basic terminologies will be discussed over here, like local computing, cloud computing, and service models of cloud, orchestration, virtualization, etc. So we just begin with local computing. Local computing is like how we access our PC, which is like right over you can see over now. So compute, it is like you have a grid between the hardware and the software to do your actions. So on the computer. So for that, what is required is three things. One is the infrastructure. You have a CPU which has the processor, RAM, hard disk, network, etc. So, and the platform, yes, you have the Windows or the Linux being running over there, and your software runs over the platform. So, which is a browser or a Microsoft Office, LibreOffice, or some games, etc. So when compared, so this local computing is a micro level picture, and if you go to a big level picture, it is a cloud. So since like the cloud is bigger, why we need a cloud is like you just need to access the globe, share ideas. So through social apps, and you just want to send out some emails or something like that. So these all are there in the cloud. And the reason we need to move is to share our idea, so use the best infrastructure and to be global. Global in the sense I can access my Gmail at my home, at my office, everywhere, anywhere, anytime at the globe. So the cloud service model is all like abstracted of processing, network, and storage. As you can see, the server, storage, network, or everything is abstracted to one model. So actually, what is a common and certified cloud service models are a software as a service, platform as a service, and infrastructure as a service. So software as a service, it is like it is a one software on a cloud. It is for all. So it is a common software where the data is different. Like the same example, Gmail. So everyone access to the same URL, www.gmail.com, and you find through your authentication, you find your data, I find my data. So that's where it's different. And platform as a service, yes. So those applications are developed on a same common platform. So for example, the most common platform is LAMP, L-A-M-P. So L stands for Linux, Apache, MySQL, and PHP. So these applications and the platforms need a infrastructure to grow. So infrastructure should be very scalable and should be faster. So to support the application and support your user request. So basically, this infrastructure is now being used as a shared resource. So at a data center, so you find all the infrastructure being there, and it can be used by n number of people. So okay. So now we are moving into some technical terms. It is the first one is with orchestration. So orchestration is OpenStack. Okay. So if I think about OpenStack, yes, what I can do with OpenStack. So then you start with first concept, first keyword. It is like orchestration. Yes. So you just need to create, update, and manage a group of cloud components. It is like an infrastructure. What all the components being there, I can manage everything as a single entity. And also I need to automate what all the manual process I did. So this is a way to, this is actually defined as an orchestration. So orchestration, so what is the delivery service? So it is like you just stitch the software and the hardware together, and you make the workflow to be automated. So this is an overview of an orchestration. So when you do an orchestration, yes, then what you do? Virtualization, yes. virtualization, it is like as you can see at the diagram, we need an application to be run. So okay, but on a distributed environment, yes. So you need 3 OS runs on a 3 hardware. So which is like the infrastructure cost is very higher, and the way to manage and the cost is ultimately higher. So this to be reduced, and this is the open up or a spark to cloud computing. So you just have all the OS runs on a one hardware, which is a high defined hardware. So where you just virtualizes each and every OS, and there is a hardware, there is a common OS being running. It is actually a host OS, and these are called guest OS. So who creates this guest OS is called hypervisor. Hypervisor is a soft layer over a kernel which spans up all the guest OS. Guest OS. Okay, so now I'm going into a next terminology. It is called virtual machines. So each and every guest OS is a virtual machine. Okay, so this is how we are going to start up with the OpenStack. Okay, so we just have a lookup of all these things, and then to the next is OpenStack essentials. Okay, so essentials in the sense, so what all we need to know. So the basic thing. So if someone asks you like, I'm working on OpenStack, suddenly they will ask you for these questions: what, who, when, where, why, how. So what? So this actually be a very common definition. So it is like provides an IaaS solution through a set of interrelated services. So what are the services we'll be seeing at the following slides. So for each and every service is an interface. It is an application programming interface. So that will actually automate all the needs, and it has a common workflow to do that. Okay, who in the sense who designs or develops and contribute to OpenStack to OpenStack development and much more. So it is actually based on the latest release. It is called Icehouse, and the before release was Havana. Okay, so the Red Hat and IBM are the top 2 organizations who participated in development for much more. And when so it is a concept from Rackspace and NASA on 2010, and to a rapid development in 2010 to 2014. It is like just for 5 years, but actually 9 releases. That is actually the mass development of OpenStack, since you have a big community to develop, to make it test, and then to make it implement and make it to deliver to each and everything. And the most important is it is an open source. Okay, so where? So where in the sense where OpenStack is being deployed. So I'm just working on OpenStack, but I don't know where this OpenStack being deployed. That is not the right way. So I just want to show you what all where the OpenStack is being deployed. So so software as a service. So to provide your software to the environment, just use OpenStack. And the research, government, information technology, in the sense the most popular ID people's users, and the most of the companies put their own platform through OpenStack. And healthcare, to provide their application to be more widely used. Cloud hosting, GoDaddy, or people like them use the OpenStack to provision each and every virtual machines to the end user. And media and gaming, it is all to scale up a big application using OpenStack. Okay, so we need to go for OpenStack. We have other open source, and which is also quite common. It is called CloudStack. But why just need to go for OpenStack in specific? So it has a very control and flexibility, and it is very easy to scale. And as I said, it is an open source, and you have a big community, and it is a technology, not a product actually. So how I'm going to use the OpenStack? So that is a big question, and so these components of the OpenStack like heat, neutron, cinder, nova, glance, shift, and celluliometer keystone, these components are the major components, and these will be discussed in the following slides. So we are just end up with essentials, and the next lineup is architecture. So without architecture, without a good architecture, the OpenStack is actually, with a good architecture, you can use the entire service effectively. So we get into overview. So the top layer is a dashboard, and below that you have all the internal components. So compute, block storage, and networking, image, object, everything. And identity as a service is you need to have a username and the password to get into this. Okay, so the concept. Okay, so when you come to the concept, so there are, as I showed you in the before slide, so there are more internal components. So how these internal components are going to communicate and then provide a solution to us. So it is all done through a queuing mechanism. It is actually a message queue. Message queue in the sense I'm talking to you and you're talking to me in the same way. So all the process will be scheduled and then it will get implemented. So for example, I just need to span a VM. So just start up with a queue. So then Nova scheduler will schedule. So where is the volume and where is the compute, and is there a space there to span my VM? Okay, so the space is ready. Okay, so then it will ask for the user which kind of image you need, image in the sense OS. So you would say like Windows, then put Windows over there, and then provide the network using the Nova network. Now it is called as Neutron. So you get the connectivity to the instance. So now you give the public IP to the end user. Now you span up a VM. So this is all done through a queue. This is the core component of a OpenStack. Okay, so the before slide is actually a internal view, and if you want to put them into a picture where you can see, it is you have one server. Server one is acts as a controller. At the networking terminology, they used to call it as a cloud controller. So the cloud controller will have the volume, network, glance, object, and the compute together to follow all the queuing process. And the server 2 is our node, so which will have it is called as a compute node, which will have as I showed you in the before slides, there will be a one hardware where more number of guest OS being running. So the guest OS is nothing but this virtual machine. So that runs over a hypervisor. So this is where it is, and the client is where you access from it. Okay. So now we
Swami, 1 minute. Sorry.
Yeah. Okay.
Sorry, Swami. Guys, if you have any questions, I'm not seeing any questions, so just wanted to let you know. You can use your chat window, just be interactive and put your questions so that the trainer will answer them. There is one question, Swami. Do you want to take it?
Yeah, sure.
Yeah. So all components in server 1 is on the same box, or is it distributed?
Yeah. So this setup is to start up with a small setup. Small setup in the sense the server 1 will have all these components, and if your load is very limited, you can go for server 1. With one server you can do everything. And if you are going to have multiple computes being there, where you can see like my requirement over here is to span only 2 virtual machines and a small app. If you want a big app to be developed, and if you need many virtual machines, one runs a web server, one runs a HTTP request, and one. So if you want multiple machines to run on a multiple computes, then this one server could not, the server 1, so which has nearly 6 components. So these 6 components could not run. So you need to distribute the load. So we will have only three things. One is Nova API, and we can have a Nova compute together, and then the rest all can be splitted into a different node. So which will be sharing in the following slides.
Thank you, Swami. Guys,
Yeah.
if you have any other questions, you can just put it on chat window. Go ahead, Swami.
Yeah. Okay. Thank you. So next we are getting into services, which is a main core for our discussion today. This is all the OpenStack services which I have updated close to this release iSource. So the first to start up with, if you needed to access application over at the cloud, you just need two things: yeah, username and a password. Yes. So that who provides that to the OpenStack, and OpenStack how it delivers to the end user. This is all done through user identity service. The component is the keystone. Okay. So this is actually the tagline for the service: authentication and authorization for all the OpenStack services. Okay. So the main function, it is like user management. User management in the sense, you will get a question. It is called the user and a tenant. Okay. User is you. User is one always, and a tenant it can be a community or a company or a group of people. So a tenant will have multiple users. So, and a role in the sense, you have an admin, you have a developer, you have a cloud administrator. So there will be, and a manager kind of thing. So so these are all the roles, and the user tenant. User and tenant, you can have it as user and the role. So all these things are mapped together to have a user management and service management. Yes. So this tenant should access only these services. Like he is not registered with us for accessing our basic images. Like for if I need to access a Windows server, which I need to put it on my VM. So you just need to pay extra so to use that. So you put an endpoint to the API call. So that is actually done through service management. So okay. So it is all like you will get all the available services which for that you have paid for, and so, and the endpoints. Endpoint in the sense, this is actually your quota to access. So with respect to storage, you are limited only to 50 GB of storage. So these are all endpoints to a particular service. Okay. Okay. So we are moving into other what subcore component, which is called a mission image. Mission image, as we discussed earlier, it is actually a OS. Okay, and it's not be only OS, but maybe Microsoft with SQL Server being installed into it, or if you can see, if you need a LAMP platform, like I said, Linux, Apache, MySQL, PHP put together in an image, so where you can load it and you get the platform within a second. So this is all done through mission images. Okay. So it is done through a component of OpenStack called Glance. Okay. So it is actually, the tagline is catalog and repository for virtual disk images. Okay. So virtual disk is for virtual machines. Okay, to be clear. So the main function is like to provides a functionality for discovering, registering, and retrieving virtual machine images. So you just need to what you can do with the virtual machine images and with the Glance, you can create your own or use the same. You can read, and if you can read and then put your software into that and save this as an image. So you are updating the image. And if you want a old image to be deleted, yes, you are deleting the image. So that is what. And you have another capability is like to search an image. So I just need MySQL running on a Linux platform. So you don't want to install P, PHP or any other components in your Linux. So you just need to search and then to get the image. And cache images, so you can, if you think like these OS are obsolete, like Ubuntu 9.04 is obsolete now, so you can actually cache that image, and if you want to test in future, you can use that. So all these image management can be done through mission images. The component is called Glance. Okay. So the main and the heart of the OpenStack is that the compute, and the component is Nova. Okay. So Nova is the heart of the OpenStack. The main component of OpenStack is Nova. Okay. So what it does, creates virtual servers. It is called virtual machines upon demand. So if you ask for a virtual machine to be created with this image, you just create it through Nova. Nova is the master, and rest of them act as a client. So master sends out an image and clients acts upon them. So this is the main core of a Nova. Okay. So the main function of that. So it is actually a platform that manages compute resources, that we can call it as the server, the storage, all you have, and the networking. If you need a subnet, or if you need a public net, or if you need to have your own IP addresses for your instances, that you can do, and you can control your cloud. So this is all can be done through Nova. And it will also add a advantage to you can add the user, the project in the sense each and every tenant will be acted as a project. So that I'll be explaining in later. And also the main advantage of OpenStack is to scale in the sense. So if I need some amount of energy in the sense cloud, so energy in the sense, so I need this much of input output for this application. So I'm limited to that. So you can use that. And if you find this space is not enough for me, I just want to span some more to be like if I'm living on a one bedroom house, so I just want to scale up to 3 bedroom. Yeah, you can do that. And if I want at the time, if I think like 3 bedroom is not enough for me, I just need to go back to the one. You can do that. So this is all like scaling and elasticity. Okay. So what are the main components of a Nova actually? So there are some Nova components which is called Nova OpenStack subcomponents. So when you start up with the first one is like the application programming interface of Nova, and the scheduler. And so the scheduler will the main purpose of a scheduler is to get the message from the Nova. So actually message from the master. The master asks to span a VM. Okay. So the scheduler will get the message from the Nova, and then it will see all the computes. So where this VM can be placed, and which compute or the host best part to put it over here. We call it as a best fit for a VM to be placed on a host. So he decides that question, and then we can come back to the Nova conductor. Just wait for me to complete Nova conductor, and I will be coming back to the queue. So Nova conductor so plays a background role where he updates a database. There is a Nova DB. So he updates a database, and this database will be accessed by the command line interfaces, the horizon, we call it as a dashboard. So when the user sends out a VM request, then it will say like initializing, then connecting, and then it is active. So all these state changes of a VM will all be updated through the database, and who updates this database is from the conductor. So why we need a conductor actually? The Nova API can does that, but what OpenStack people did was they wanted to reduce the load of the Nova API because Nova API has a set of instructions to be done. So if it takes a part to update the DB, it is an overload for it. So they have a separate module which is called a Nova conductor. So this is the main purpose of a Nova conductor is to just to update the Nova DB, what all the messages being given to the conductor. This is what. And coming back to the message queue. Message queue, there is a queuing mechanism is called the AMQP protocol. AMQP is it is actually a common messaging protocol. It is called as Advanced Queue Machine Protocol. So over here you have 3 people implemented that. One is commonly used, which is called a RabbitMQ, and the next is Cupid, and then ZeroMQ. So most often used queuing mechanism is RabbitMQ. So what does this queue do is like it just passes out all the images from the source to the destination, and it will act as a connector between all these components. So this is what. And compute worker. So okay, some as you can see, a Nova scheduler has a decision to do, and Nova conductor has a role to write to the DB. Message queue is to pass the messages, and Nova is to manage the whole network. So okay, this all where it goes. It goes to the Nova compute. All these decisions, all these updates, all these commands, all comes to the Nova compute. Nova compute is actually a worker. So all these people can be a manager or a tech lead or something like that. And Nova, the compute worker is actually an engineer who is going to perform this task. Okay, so Nova compute, where this Nova compute will be on? It will be on the server 2, which I showed in the last diagram. So server 2 will have a Nova compute running on. So so over here the main controller will send out messages through the messaging queue to this Nova compute. What all the messages will be like: create this VM, delete this VM, and provision this network, things like that. And there was a you need to mention this, there was a component called Nova network. Still it is there, but at the Nova level they removed the Nova network, and they made as a separate entity called as Neutron. So Neutron is now a networking node. We had a storage node, we had a controller node, we had a compute node. So now we have a network node. So this being done from the Habana release, and now it is being enhanced in the Isos release. So what does this Neutron does is like, Neutron would say like a neuron in the sense it is the main nervous system of OpenStack, where it connects all the components of the OpenStack using the management network, and it provides a network for the between VM communication, and it also provides a network to reach the public network. So all these things can be done only through a Neutron. Okay. Then as like of Neutron, there is a other component called Cinder. Cinder, what it does, it creates a primary storage. We say like our local compute has a OS being running, and for that it needs a hard disk. So it is a volume. So it is actually a volume worker which was there before. It is called a Nova volume. Now they are also made this as a separate host. It is a separate node which is called a Cinder node. Okay, which is actually a block storage. Which would be okay.
Yeah, Swami, can you please let me know when you are ready to take questions? I don't want to break the flow. So if you are ready now, or if you want some more time to complete topics and take the questions, I have a few questions waiting to be answered.
Yeah, I can answer. No problem there.
Okay, so you want me to go ahead now?
Yeah. One question, and then I'll just complete 2 more, and then we'll discuss the next question.
Sure, definitely.
Yeah, okay.
So okay, is image can be backed up and used for later in case of requirements, offline store. So what about existing data in case of image shrink?
Okay. Okay. So this is actually a good question, and there is an image. Okay. So we which has a, it can be a first level image. First level in the image in the sense it has a OS being there, and then there is a platform also there, and there's actually a second level of an image, and then the third level of an image can be an application. Okay. So all these can be an image or an image which is running on a virtual machine. Okay. So if I need to store this image, you can actually do a concept called snapshot. Snapshot, what it is, when we go back to the olden era, so we have a Windows. Okay. So there is a restore point. If you go to the restore point, your old data and the old application will be retrieved. In the same way, if you take if you are working on a virtual machine, okay, so you just take a snapshot of the image. So then you store it in the Cinder, or I will show you now. Now I want to mention it as a storage node, where you can save this image in a storage node, and you can actually this image could be, you can mention it as like my system is running proper, so I just want to save this for any one-time failure. One-time failure in the sense, if a VM goes down, if you do some for example at the Linux platform, if you do some rm-rf, if you remove some files. So I don't want to do upon a one-time failure. One-time failure in the sense, if you do that command once and your data is being lost, that's all. So the data can be accumulated data for 1 year, so the entire work is get into a crap. So based on this snapshot technology, so you just get the images which you are made a snapshot in the storage center, and you can boot that image into a new VM. So this is what this snapshot will also be used in scaling. Scaling in the sense, my VM has only 2 GB RAM. I just want to increase it to 16 GB RAM. So this is all like they will do a snapshot of this image, and then they will expand it. They will actually shut down this image, and then they scale up to 16 GB of RAM, and then the same image will be replaced for you, and you will start from the point where you stopped. I think I answered your question.
So, here is one more question. Yeah, so related to this, one more clarification. So this, when you say OS, hardware, and application, are these three images are different, or it is all the snapshot is a one shot, one dump which includes all this hardware configuration and application and OS?
Okay. So I would say like OpenStack is not a big orchestration or something that you just put your question on your local computing itself. So you have a restore point, yes. So you have your hard disk, okay. So if you replace that hard disk with some new hard disk, will the snapshot will come? No. The same way. So and also the snapshot, so it will have the same OS, same and everything. This is all stored on a hard disk. Hard disk, we at the OpenStack we call it as a storage node. You just save the snapshot at the storage, and this will get replaced when you want it. So it is all like it is a virtualized environment where you can't see like the processor. The snapshot will take everything. What is the processor load you have, and what is the RAM you had it before, and what is the OS and everything. So you just have as an image, and then whenever you require it, you just put it over there. So it is a virtualized. So it is all like You just take a snapshot, put it on a storage node, just don't care about anything, and the storage node is actually highly replicated. So your image will be stored at different n number of storage nodes, and so you will have a high availability in the sense. So at the storage node there can be a image. Okay, so if your image is lost, if there is a earthquake being there at the data center, then your image getting so it is not a one-time failure. So you will have your image being replicated at n number of servers. So whenever you need it, you will also get it faster. The image will also download it very faster. So this is how it works at the OpenStack and at the data center. Yeah. Yeah, I'm just proceeding to the next slide.
Actually, there are a few more questions, Swami. Do you want to take them?
Yeah, I'll just complete some 2 or 3 services and then maybe
Yeah,
some
sure.
after
Let me know when you're ready. We can take the other questions. Thank you.
Yeah, sure. Okay. So I find some more questions to be interesting. So we'll have a picture into the storage. Since like why I just want to complete some services and then take part. The question is like, so when you read about the storage, then there should be the before question would not be arise. So that I just want to complete it some 2 or 3 services. Okay. So coming back to the services of OpenStack, so let me start with storage. Okay, storage, and in the before slide I had only compute, but over here I have storage, and next to that it is an object. Okay, next is block. Okay, so you find it different. So object and a block. Okay, object in the sense at the programming level or whichever, it is a independent thing which is called an object. Okay, so and a block in the sense it is actually a entity of all or just a huge thing. It is called a block, and when you see that the when you have a storage at the micro level, it is called an object. Okay? Which is an abstract thing. So what is a component of OpenStack which provides this object? It is not only the OpenStack component, and it is actually a wide used component which is called SWIFT, shift. So as you can see at the bottom of the slide, you find Windows, SkyDrive, Dropbox, and Google Drive being there. So all these are used by the end user, that is you, and they are using these kind of services called shift to store all your images, store all your files, I would say, and these files are highly replicated in the sense they will take multiple copies of your files, and this will be stored at different zones. Zone in the sense, for example, we are at US. Yes, US will have some 2 zones which your files will be present. When you access it frequently, it will get replicated into multiple different availability zone in the sense data center location. So it will get replicated in Singapore, it get replicated in UK, it gets replicated in China, over there, it across geographies. So why this mechanism being in practice is like if there is a geographical what damage, I would say, earthquake or something, tsunami or something like that, which happens at China or Singapore or over there, your data center will be lost, but not your data being lost. It will be stored at the US and the UK, where you can get your files. So this is how the shift logic works. So the tagline for this is to store or retrieve files. That is all. So what is special with shift? It is actually a file level access. Yes, you can only upload a file, so you cannot upload a block. So each and everything you upload, it is all a file. Okay, I think most of them would have used Google Drive or Dropbox or SkyDrive. You find it very easy to understand this concept. So file level access, in the sense, you just upload your file, you can share it to any number of people, and at anywhere, anytime, anything it can be, and you can access from any points. It is like with mobile or a laptop or a OS, very at UK, US, everywhere you can access, and it is all with a URL. So you will have a URL, and the for each and every file you will have a URL, and those URL can be shared with the people. Okay, so using this, Google Drive comes up with collaboration, things like that. So all this being works on a, we would say, may or not be working on an OpenStack, and then OpenStack, the Shift service will be, the storage service will be of high importance. Okay, so why we use Shift is like to store the file for a long time, and over here the Shift, the main advantage is like you cannot say like you can maintain many multiple versions for your file, where you cannot do that in the block storage. Block storage is that your hard disk. So at the hard disk, what you need to do is like V1, V2, V3. So this is all the mechanism to be followed at block storage. But over at the file level access or object storage, you just need to continue your work, and for each and every action there will be a version being present. Okay, so this is how it works, and due to this, so it can be retrieved, it can be leveraged, it can be updated. So anything you can do with the one file, and it can be also be shared. So this is all, and this file will be a long-term storage system. So you can have a file today, and after 25 years you will find that file being present. If you go and do a manual deletion, it will go from all the replicated environment, and it will not be retrieved again. So this is how. And in the upcoming slides, I will show you what all the best advantages from object storage, and what is the best advantages from block storage. Now we can see like a block storage, which would be a useless thing, and but it is not. It has its own importance. Okay. And so, as I said, it uses a distributed architecture. Distributed architecture in the sense you have the same object storage at n number of geographies, and you will have a central point of control. There is no central point of control. Okay, so going to get into block storage. Block storage is called Cinder. Okay, so the tagline for it is like persistent block storage to guest VM. Guest VM, guest OS, everything is same. So it is actually a storage option. It can be a primary storage. This is actually a secondary storage. For a primary, secondary in the sense, primary is like it is very near to the VM, and secondary storage, it is like it is far away from VM. Okay, so yeah, okay. So it is actually a persistent block storage to guest VM. So the functions is like store resources to end user that can be consumed by Nova. So the Nova can access these volumes, and this can be given to the VM. And Cinder, what is the main functionality of a Cinder node? Cinder is now a separate node, and if you take as a storage node, the Cinder and the Shift can be at the one system, or it can be at the two system, or it can be at the multiple system. So this is all based on your requirement. What is your requirement? If you need to run a one application which will need n number of resources, then you will have a setup which with too many controllers and thousands of compute. So there where you need to figure out how many Cinder I need, how many Shift I need. So this is all architect planning of a OpenStack environment. We would say like cloud environment. Okay. So over here what I can do, so with our hard disk, what it will do is like if I give a hard disk to a processor, it takes the OS from the boot and it boots the OS for us. So in the same way, this Cinder will act as a secondary storage, and this Cinder can actually gets mounted on a host OS, and then from over there the guest OS, it's called a VM, can be booted from this partition. So this is how it works actually. So so what is the use of saving it as an the VM storage, which is very essential for VM, which has the application with that and the OS with that. So VM is like you have for a machine, you have the OS, the application being running. So why do I need to store it at the secondary storage? Since it is like it is actually for a migration purpose. Migration purpose in the sense, if I need to have a VM which is at a host which has a limited number of RAM. Okay, it has only 4 GB of RAM remaining. But actually, what is your request is, I just want to expand it to a 16 GB of RAM since my requirement is heavy. So what a cloud administrator can do is like he can take that VM and he can migrate it to from one host to a other host. This can be only be possible when you use Cinder as a storage. So this is the main advantage of a Cinder. So this could not be done through Shift. That is actually the Shift could not provide a boot or a migration or a storing point for a VM. So this is actually a big difference between the Cinder and the Shift. And I will also let you know more number of differences between Shift and the Cinder. Okay. So and one in addition to that, your images can also be stored at the Shift, since it is a file. You just want to remember. So each and every image is a file. So you can put it on the Shift, and you can actually you can request the Shift, and the Nova will request the Shift to get the image for to span the VM. So this is actually a use case which is being there. Okay, storage. So two giants, Cinder, Shift. So each competes with that. So the first is like the Cinder, which is a block. It can be used as an additional storage, but this could not be used as a additional storage. Used for storing virtual machine images and data, but not the virtual machine. So that is actually the main big difference between these both two. And so Cinder, VM can only access a Cinder, but over here the user can only access the Shift. So it is all like it is available from anywhere. Okay. So Cinder size based on need. Yes. Since like Cinder can be have a maximum of 1 TB, since our hard disk or generally a block storage, which is a hard disk which can be have only a maximum of 1 TB, for example. Maybe if I'm talking, so maybe in the tomorrow you will have a petabyte or something like that being developed, but I don't know. To my knowledge, it is like 1 TB is a maximum. So the Cinder one volume can be 1 TB. Cinder can have multiple volumes, so that you can increase that, but it is all based on need or on demand. So this is actually a small drawback with Cinder. Okay, when it comes to Shift, no, it is not like that. You just can scale a multiple object storage system using the Shift. Since it is like you can add more number of hosts to the Shift, and then to grow the size. So it could say like the star is to multiply. You can have thousands or lakhs or billion number of TBs to be running. So that is a major advantage of object storage. And I think like some would have read about Amazon Web Services and all. So they provide infrastructure as a service, maybe through OpenStack or with any other thing. But over there, what they do is like when you use the Shift, they cost it. You will have a higher cost. When you use a Cinder, you will have a low cost. So that is actually the main big difference in a business case when you use a Shift and the Cinder. Shift is actually highly available. Cinder is not that highly available with compared to Shift. So this is with we are did with storage, and this is actually a important component which I mentioned it as neuron of OpenStack. So without the nervous system, how a body can be. So the same for an OpenStack. OpenStack, yes, it can have multiple nodes, it can have multiple functions, features, yes, everything. But if all could not be connected, then it's of no use. So the same way our brain and legs, hands, and everything are connected through bones or something like that. But the neuron is very essential of a body. The same way, neutron is also very essential for a OpenStack. Why it is essential? Since it provides or gives you a network connectivity. If you say hi to a next host, he will reply back to you hi. So that's just the communication, and through that communication only the cloud is being active. So so what is the main function of a network? So like it can create, attach interfaces, so to be managed by other OpenStack services. So and also the next point is like to leverage different networking technologies to power their cloud networking. Okay, cloud networking technologies. What is a networking technologies? Networking technologies like if you have a basic knowledge on networking, then we have a like DHCP model. DHCP model, the compute request for a IP address. Since it needs an address, so that it can send out hi. If you say hi from a number, so you just need to mention who are you, and then you need to say hi. Then only the person can reply back to you. If you didn't say who am I, then who will respond to you? So that you just need an IP address. So to send out your request and to receive the response to particular to you. So it is all done through IP address. So to provision that IP address, we need some n number of protocols. The basic protocols is DHCP. You will have a particular IP address, permanent IP address for you. Okay. So and the next level is like you need a virtualized LAN. It is called a VLAN. So VLAN, it is to if you have a group of people connected to you, and you don't want your information to be spread to the next group. It should be within the group. So then you need a VLAN. Over here you will find a term called tenant. So if you have a user communication, DHCP is enough. If you need a user group communication, or within user group or across user group, you need a tenant. So through that, you just need a VLAN to be there. So it is all two models. One is a flat DHCP model, and then next is a VLAN model. These two are the most used, and to the advanced networking technology, we have tunneling process where it will fasten the communication between the VMs. So we have GRE tunnel, we have a VXLAN. VXLAN in the sense VLAN is only limited to 1.2.4, and then if you want to increase that 4096 actually. So 4096, so if we need to increase, if a tenant could not have only 4096 users, so it needs to expand, so that they go for expanded VLAN. So it is called a VXLAN. So this is all advanced networking technology. Where OpenStack is being more focused on the networking technology, since the competitor all had arrived with a big networking technology, and they are moving advanced. but actually OpenStack concentrate only on the technology but not on the networking. Now they have started to focus on networking, which they will provide some more innovative solutions. Now what all the solutions they provided as a networking, which is all being present before, but they are in a process to enhance some more to be a part of innovation to a networking in the cloud environment. So okay, there is other new technologies being there at the iServe. It is like load balancing and firewall. Load balancing is like if you send much more data, like if you are downloading a image from a sender or a shift, then what is actually the route you need to follow so that all other components interaction should not be disturbed. So you balance a load for effective communication. And there is a firewall. Why we need a firewall is like your instance can be accessed from your public network. For example, you can create a VM and the VM will have a public IP address. If you do a remote desktop to your public IP address, then you have a OS being there and you can start working on it. But if you send out some virus or something like that, then the entire cloud network will get affected. So they have a firewall system to protect your communication between other, and also the public network and the private network will be controlled through the firewall. The firewall is also available at your Windows PC. It's a Windows firewall. The same technology is being used at the cloud. Okay. So this is actually the last service, and which is a best service where all the people requested for, like I just want, if I need to span a VM, I just want to follow the same process, the routine process to do that, which is a hectic job, and there'll be a more number of resources being wasted. Maybe I just need to put assistant for doing that, or I just want to more number of user to do that. So to avoid those things, we need to do automation. So no routine jobs. If you have a routine job, then create a template and put it on a sender or a shift. Then you just call that template. Then your automation starts. And automation in the sense, you just provide what is the tenant user ID, and what is the image. Example, I just need to put only Ubuntu, and you just need to have this much of RAM and things like that. So all this can be automated and through a template, and that template can be used for spanning multiple instances. So this is what which is actually a effective use of OpenStack. So heat. So through that you can just create what all the so where my VM and so this is actually an advanced feature of a heat. Like you can have a topology where is your VM, and if there is if you have two more VMs, then where which host can I put it. So all these advanced visibility can be provided through heat from OpenStack to the end user. So this is all can be done through the orchestration. So as we did with the services of OpenStack, so we saw Keystone, Glance, Nova, the giants Shift and Cinder, and then Neutron, Heat. There are much more components being there, but actually to an initial level we are focusing only on the most common and most popular and most basic services of OpenStack. Okay, so this is actually the last. I'll just complete and then I'll just take up the questions. So this is actually a dashboard which is called Horizon, or generally it will call as a dashboard. At Ubuntu, when you see it is all will be like Canonical, the company, and they have their own Horizon. And if you go for Red Hat or CentOS, what I'm talking about is like the controller. The controller will have a OS being running. So that OS can be two types actually, two groups actually. One is with the controller. I just want to recap is like the controller node where your OpenStack is being installed can be run on two different setups. One is with a set of groups like Ubuntu, which has its own way of installation, and the next group is like Red Hat and CentOS, which has its own level of installation. So at the Ubuntu level, at the canonical, it will be has an horizon, and over at the Red Hat and things like that, they call it as a dashboard. So both are one and the same. So what they provide a web-based user interface for OpenStack. It is actually the the projector of OpenStack. Projector in the sense whatever it's being done at the internal level will be pulled out to the database, and through the database you can this web-based user interface will access that database, and then it will be updated with the database, and your statistics and the status will be populated at the user interface. You can do a monitoring, okay? You can do a management, and you can do manipulation, and you can do much more things with the Horizon. What all things you can do with OpenStack, you can do it through Horizon. So that is a user interface. Okay, so what all can be done through Horizon? Instance management. Instance management is like create, delete, and update. What all you do with the instance. Instance is nothing but the virtual machine. You can do anything with a virtual machine through this Horizon, and you can actually create, delete, or update user access and security system for using for all your tenants, and that can be two people. You can be a end user, or it can be a cloud controller, or it can be a tenant admin. So whoever it can be, all can be accessed through Horizon. And flavor management. Flavor is actually image virtual machine images. So flavor management, so you can create many much more images, and with a number of types you can group them. All you can do, whatever you can do with Cinder and Glance, all you can do it with Horizon. So image volume management, it is all one and the same. You can do the same with the flavor management. You can do the same with image and volume management. And object storage, so you can access your Cinder, what is the space the Cinder, the shift task, and things like that. You can do all these things. And if you want to do a planning in the sense, if there is a request for new expansion enhancement of your cloud environment, you can plan before. You can be proactive. The cloud admin can be proactive in the way how many nodes are being required to scale my data center, and is that I just need to expand my cloud environment, or I just need to find the other availability zone. Maybe I'm in Singapore. I just want to have other data center which should be at the extreme end, so it can be US. So I can have a setup over there. So all these planning can be can have an interface. It is called a user interface that is being used with Horizon. So all these interface and things like that are done through Python. So this is actually a snapshot of this OpenStack Horizon. So where you can see how many instances are being created, CPU, RAM, floating IP, so things like that. You can see from here. This is only the overview of a sample project. So at the upcoming classes, so we'll have all the hands-on experience on a user interface, and moreover, more with the user interface, you will understand the technology less. So if you go with CLI, which is a command level interface, so then you will get to know much more things actually. So this is all possible. Your innovation will be starting up, or you can innovate much more with using the CLI, where user interface is only for some common purpose. So this is actually how we can access the OpenStack. Okay, so now we are end up with, and I'm just ready for the questions. Hello, Srikanth?
Yeah, Swami, are you ready?
Yes.
Okay, the next question is, what database will be commonly used in OpenStack? Like, what kind of options do we have?
Yeah. There are actually two database being used. One is MySQL and another is PostSQL. So it is most used is MySQL. It is called MySQL. So we call it as MySQL.
Okay, thank you.
Okay.
What are the interfaces to the end user and between the services?
Okay. Which is a very internal question. So interfaces in the sense mean like API interface or the network interface. If it has a network interface, we have a we need to have a small lookup like for each and every as I've shown in the essentials of where I can show you two architecture for virtualization, where you find three hardwares running three OS. So over there, each hardware will have its own IP address as an interface to communicate. But over here at the virtualized environment, you have one hardware, so that you may think like I will have one IP address, but it is not that way. When you go back to the old network where we had three OS and three hardware being running, all these things are connected to a switch, where that switch will route your packet between the system. The same way, where the guest OS, where the VM being there will be a virtual switch, and the common used virtual switch is open virtual switch. So we call it as OVS. So with using that OVS, it is actually acts as a virtual switch. In the sense, all these VM will get its own IP address, and those IP address will be different from the management network. For example, the management network can be with 192.168 one dot some network, whereas this this VM network can be of different network. It can be 10.0.1 dot something. So it can be like that. Why we need to have these two things is like we don't want to interrupt the management network with the VM network. Since if you lost this management network, you could not access that compute, which is a one-time failure. So if you need to access your VM, you can just go through this network, which is called a 10.1 network, which is entirely different from the management network. So this is when you think about one host, it would be clear. If I have a 10 number of hosts, 10 number of hosts in the sense 10 number of computes, then you'll have all the VM being at the same network. So that was I was mentioning it is like flat model, which is a DHCP model, which will have all these VMs all will be in a one network. If it is a user-based OpenStack, if it is a tenant-based, so there will be 3 or more tenants are using the same OpenStack environment. Then we put a VLAN on all these the VM networks, so that all these communication between the VLAN could not be possible. So that way we encapsulate the communication between VMs. And the management network is for the for managing the computes. So if I need to see, and if I need to access the hypervisor, things like that, so I just need to have this management network, which will be so that it will the compute will have two ports. One is called a management port, and one is called a VM traffic port or a data traffic port. So that is where in upcoming classes it will be the networking will be in very detail, since like the networking is a core area for OpenStack to develop on. Next question.
Yeah. What is an OpenStack exactly? Is it a concept or technology?
Okay. Uh, where most of the contributors and things like that. So there is a vast area of contributors to the OpenStack synthesis. This being an open source where you find the big level of innovation. So we could not make this OpenStack as a one single product. So if you do it as a one single product, then you're limiting only to a one user group. For example, there is a other software which is a competitor for OpenStack. It is like CloudStack, which is being from Apache. So it is actually designed only for data center purpose. Data center which I need to span up with this orchestration, then it can go for CloudStack. So, but over OpenStack, it can also do with data center. It can also do with public network, private network. It can do with any it can be scaled into anything. So it is called as a technology, not more. It is more of a technology, not as a product. Since
So
innovation is bigger. Next question.
So is there any
Thank you. Yeah. What is the is someone talking or?
Yeah, so this is Ganesh. So my question is there any there's a question on that OpenStack is technology or it's a concept. So basically, is there any, when you say it's a open source and a lot of people are contributing, is there any body or some organization or somebody who controls that and who validates what needs to be added into that or is not?
Yeah. It is there. It is not like I can develop some enhancement on Neutron. I can provide to the OpenStack. So you can contribute your part to OpenStack, but there will be a project lead for each and every project. So it is actually the first level you see. For example, if you are with a new concept with Neutron, so see like I have some new innovation to the Neutron, so you can send your code to you can do a commit to the OpenStack main area, and there is a lead engineer, technical lead for this project. He is called as an project tech lead. So he will actually go through your modules and he test it, and then if he finds, and then he talks with the core people who will be the main contributors for OpenStack. Okay, so they decide upon this feature is okay, good, and we can enhance it. We can actually integrate with Neutron. Okay, so after integrating with Neutron, there will be set of people to test whether this existing thing is being spoiled or not. Okay, so they tested and everything is done. There is a main core people over there. It is called Rackspace, who owns decision making of OpenStack. But actually, they are very open to the innovation, since the product should be of very useful to the user as well to the enterprise. So the enterprise is the main key people who comes up with more requirements. Those requirements can be addressed by the engineers who can develop their code, and then they can put it over at the Neutron, sorry, OpenStack server. So for each project, they have a different servers. So over there, you can put your code, and then they test it, and then the requirement of an enterprise comes into picture with your code. This is actually how they work on. So who is the enterprise? Enterprise is HP, Dell, Cisco. They have who are the people who has more number of network devices at the network, at the real network. We are actually connected together in a webinar. This is all done through a network. So our data is being sent and received through n number of switches. So who owns those switches? So they are the main enterprise of the network area. So they are more focused on this OpenStack development. So they comes out with more number of requirements, and these requirements will be addressed by the engineers, and the requirement which is very required for this next release or not, those decisions will be taken by the main core people. We can at present we can make it as Rackspace, but there are a number of people, but the main people is Rackspace who invented this. Next question.
Will Neutron not choke network? Is it not bottleneck for bandwidth?
Okay.
I don't know what exactly the question was, but
yeah, okay. Neutron.
So basically,
just like
okay. So
sorry.
I'm sorry. Sorry to interrupt. Basically, I put this question. So basically, the question was like when every entity of every components in OpenStack has to go through the Neutron. It will be so Neutron is the one who manages all the network related queries and other things. So the question was, will it not? Is it? I mean, all the traffic. My assumption was all traffic flows through Neutron, and will it not choke the network bandwidth?
Okay. So yeah, it is actually, if you put across your question with Nova, there's actually a controller where they find they could not handle this volume and network component, so they made volume as a different entity, separate entity, and Neutron as a separate network as a separate entity. Why? Because to reduce the load of the Nova or the controller node. The same way, if there is a actually at present Neutron, it creates the first time when you create a VM, it creates a communication channel between what all the request between all your tenanted VMs. So it is a one-time process. So for example, you get a new PC to your home, and which is actually a second PC for you. You just connect to your LAN. So okay, LAN assigns a DHCP IP for your system. That is all. That is a one-time configuration. That's all. It was did actually, and the first PC and the second PC all will be connected together. So you just they establish the connection. That connection will happen through your router or your switch. That is all. The same with the cloud environment. So and there are some situations where there is an application which actually access network as a main core area. Like if I'm going to do a traffic generation using this OpenStack environment, then what I can do is like I need to replicate this Neutron to a master Neutron and the slave Neutron. Over the master Neutron will actually load balance with the slave Neutron. If the master Neutron request is full, then the slave Neutron takes up. So the same technology. So it is called high availability. The same way for a controller also. If the controller, if the cloud admin decides that the controller is very slow, then they replicate to one more controller, and both these controllers are connected together so that the load is balanced, and if one controller goes down, then the other controller takes apart. So it is called as an high availability to reduce a one-time failure. That is all. Next question.
So yeah, the next question is, what is the difference between OpenStack and Amazon services?
Okay, Amazon services, it is for OpenStack, what you need is the infrastructure, and over at the infrastructure, to use the best part of your infrastructure, you just need a OpenStack. Okay, this only for people who has the infrastructure and to use the best part of the infrastructure. So they go for OpenStack. But if there is a user, I don't have any infrastructure, I don't want to spend cost on infrastructure, where rather than I can I can work on my main goal. It is to develop a best application, things like that. So for example, we can take innovation company which is more focused on the application, not on the infrastructure part, which is they are not good at it. So what they do is like they outsource to other company, where this Amazon Web Services, it makes a big role over, it gets the outsource request from a big company and does all the services to the company. So where you can approach the where I said like OpenStack is a technology where all could not access the OpenStack. Okay, so so the technology will be at the back end, and the main product will be at the front end. So this is how the main the cloud area booms up. So AWS, so they will not say like I'm using OpenStack, Cloud Stack. So they may say like I'm having my own stack to do that. So it is all like that. They would not share the main source of their technology. So basically, Amazon Web Services uses the same thing. They have a keystone, but they rename it to user identity service, and then they have the glance, which is actually called as an EBS, like elastic block storage, and Shift is actually S3 simple storage system, and so it is like that. Neutron, over here, Neutron has a number of advantages. Over at the AWS, they call it as an VPC, which is a part of a public cloud. They call it as a virtual public cloud. So you just have your network over there. So that is all. Heat and all, it is like they have a cloud formation system. So over there you can generate your own cloud with some templates. So they are one and the same, but OpenStack can be used only by the people which has the resource and infrastructure and things like that. So it actually a technology to work on to provide the request for the end user. So the Amazon Web Services gets that, and from your browser you can just go to the Amazon console, and you actually the Amazon console, it is actually Amazon API and the OpenStack API. So Amazon API is acts as a front layer, and the OpenStack API acts as a backend layer. So all these requests to this Amazon API will get through this OpenStack API. OpenStack does all the areas. So this is how actually works. And we cannot say Amazon only uses OpenStack, but it has n number of orchestrations and orchestration software. It tries all the things, and then so that he will be the best giant in the cloud platform, providing the cloud platform. Next question.
Thank you, Swami. The next question is, how will these copies as part of Swift in sync? If yes, how fast is the sync? How fast Swift sync the data between replica of files to avoid getting chance of older data file?
Okay. So the best answer to this question is like just go to the drive.google.com, put some files into the drive, and then see how fast it is. And it is all based on your internet. So if your internet is faster, just upload it in fraction of seconds, get the data in fraction of seconds. So you can access through anywhere, anywhere. So it is all like that. So for each and everything, they have a configuration management. So using the configuration management, they can store all the versions of your file, and which will all be as a separate file with the different versions being put out in the Shift. So it is like that. If the best answer is like just go to the drive.google.com and use Google Drive, and also you can try the SkyDrive, Dropbox, things like that. You find the answer over there with the hands-on answer. Next question.
Cinder can be SAN. I mean, can SAN, any SAN storage can be used as Cinder?
Exactly. Super question. So the backend is actually a SAN, the storage area network, and I think like the same question. There is other technology called NFC, NFS, so network file system. So all these can be a Cinder. So Cinder is like a one common. So as I said before, with Amazon, they have their own key terms, and there will be a Cinder backend. So how this Cinder being created is like collaborative and a collection of all these layers for your. It is actually the decision taken by the cloud administrator. If he is good at the SAN environment, then he goes for SAN. And if he finds NFC, NFS to be best thing, then he goes for NFS. And most probably all uses with a combined technology, so that they need to use the best in the world, all open source. Yeah. Next
Thank
question.
you, Swami. The next question, I think I will jump to a few questions because there's only one participant putting up all the questions. Does load balancer required at Nova compute level also to handle more end user requirements?
Yeah, I think I addressed it before. It is Nova is nothing but the controller, the cloud controller. So if there is if the cloud admin thinks that there are more requests and responses, the transmission and receiving from the controller is heavy, then it is a high time for the cloud admin to do to create a master, to create the existing controller as a master and put a replicated controller to have a load balancing. So which is actually very obvious. You just think over, like, OpenStack is a big environment which thinks about all these things, and there is a provision for everything. So just think much bigger than this. Next question.
Thank you. We can do network management also using Horizon, right? I could see network also in dashboard in the latest version of DevStack.
Yeah. Yes, you can do it from high source. They are into a new service called network as a service. Before storage as a service, then compute as a service. So there are more number of service being there. Now they introduced network as a service. When OpenStack introduces new technology, the same can be updated over at the Amazon and other people. So it is possible through you can do the networking part, and over the Horizon what you have seen is very basic thing, and actually through command line interfaces and all, you can do much more than that actually. Maybe if you are working on DevStack, possibly you would have went through all these things on the talks.openstack.org. Yeah. Next question.
Yeah. Is there any scope of automating in Horizon?
Horizon automation comes when like if you want to do some routine process to be done, but I don't think so. Like there is an automation being done at the at the Horizon. If there is some automation to be done, they can do it at the heat. So if you want to do some so if I want to select a VM image, then network, then storage, all these things, all three shots can be done at one shot. This is called as an automation. The same thing can be achieved through heat. So Horizon is only where you can do a one-click process. That is all. So there is no actually a need to automate the Horizon itself. Maybe a testing can be done. If there is a new component comes into the Horizon, the testing can be done through automation, but the process is not automated. Since please think over, if we have a real-time setup being run, more thousands number of people are being using it, no one will do automation of the horizon. So if we cannot trace back the what is being done over there and all. So this is just my idea. Yeah. Next question.
Thank you. The next question is, how Horizon is different from Heat? Is Heat command line or GUI to automate?
No, we can say like a template. No.
I believe Ganesh is.
Yeah. So, for example, I think like some people have used actually a template. I think you have a big question with the temp. What is a template and what is a UI? Template is actually like, for example, if I get a call, I can have a text template. So that text template can be accessed through this UI. So both are miles apart. So it is not like Horizon and Heat are one. Next question.
So how is this Horizon is different than, I mean, what is the difference between Heat and Horizon? Is that the...
No, you just think over. Heat is actually an orchestration. Okay, so how you do an orchestration? So if you don't, if you have a keyboard and mouse, and if you want to see something to do that orchestration, so you just need a interface. It can be a horizon, it can be a CLI. So if horizon being there, you can actually do this heat only through the horizon.
Okay, thanks.
Next question.
Yeah, I believe we have. I'm just checking. Does load balancer is required at Nova compute level also? Did you answer this?
Nova compute? No. Nova is different from Nova compute. So okay, at the compute node, if there is no need of actually load balancing, since like it is all very streamlined. Streamlined in the sense this compute will actually get the request only from these number of channels, so that they create a tunnel between all these between the computes. So we are just we have an planned architecture for a compute. This is actually the workload and this is the thing. And if there is a improvement or enhancement on the virtual machine being run, so then the virtual machine can be migrated from one thing to one virtual machine. Sorry, from one compute to other compute. And to answer in depth, it is like it is all done through, if there is a huge number of requests coming to a particular instance, what they do is actually the cloud admin used to monitor this process. If he finds there is a big response for this instance, he will just scale up the instance to a higher number of RAM, higher number of processor, and also he actually increases the connectivity. Like I don't know how many of aware of, like our PC and our modem is connected with 100 Mbps connection, and there is also a 1 gig connection which can be made between the ports. So that is all based on your requirement. If the cloud admin decides, yeah, I can do with 1 gig thing, then he will put a 1 gig connection between where the port receives a higher number of load. So this is all a step one process. So if there is a much more load, or if the instance is being highly required and all, so the same instance can be made it highly available. Like you can have a snapshot of this image and you can put it on the other compute, so that the load is being balanced. This will be done, all the connectivity being increased from 100 Mbps to 1 gig. So all this being done. After that, if they find it very drastic to be increased, so they do it like that. Next question.
Yeah. Neutron, is it not bottleneck for network bandwidth? Is Neutron a broadcast network?
No, Neutron is not a broadcast network. He knows where is your request. He receives the if he receives the command, he only thinks over like where I need to receive the deliver this command. So he knows where all your nodes are, and then he sends it to your particular node. Just think over like if I'm doing a Skype call from one end to other end, will there be a broadcasting to all other nodes, and then so it is not possible. It is like it just goes to the main network, and then the main network knows where your destination is. Then it gets switched out. Then it gets routed to it. That is all. So it is all like it is actually a technology, and it is very internal process are very automated, and we are into a generation where this network and things are being much stronger, and it is like we are 20-25 years there is a drastic development of network being there. So all these things can be done through at the planning phase, and after the planning, so everything there is a tunnel being created. All the communication can done through the tunnel, and if there is no tunnel, then they find it through IP address to reach it. That is all. It is all very basic actually. They don't as you think they will not complicate much more. They will have a very simple network with exactly what all the subnets they need, and they will have a very clear architecture in place. It should be easy to scale up and also easy to troubleshoot. Yeah. Next question.
Yeah, I think that's pretty much it. I believe you have answered almost all the questions. I have one question, Swami.
Okay.
What kind of like if do you need? I have servers in Canada. I'm going to introduce about CATI technologies so that people understand what kind of professional organization we are. But can you also talk about the training classes? Like what is your plan if you need servers? I have servers set up here, so we could use that. Or what kind of support do you need from us?
Yeah. Okay. Okay. So. So basically, to start up with, we just need some three PC, I would say, three PC, all with a decent configuration. Decent configuration in the sense, mostly you just get i3 processor and at least 4 GB of RAM, so things like that. And 3 user PC and 1 user PC can be of with 8 GB RAM, so that can be used as a compute. So that is, and all three PCs could be reachable. That is actually the plain requirement. And as you can see at
Okay, sure.
the slide, okay. As you can see at the slide, it is like the total course will be with 35 hours, and it will be very in depth. And I would say you will not be a intermediate level with OpenStack, since there will be a learning between us. So it is not like I'm an expert at OpenStack, so I will also learn along with you, and I just deliver a maximum innovation from you. That is actually a main aim to make this course. It does not like learning OpenStack. It does actually, you just need to do some innovation and at the OpenStack, and maybe at the OpenStack technology, or maybe at the management, or maybe at the using the OpenStack. We just need to bring up some innovation, and at the end of this course we will be surely delivering a set of architecture or a set of management capability to the OpenStack, which is being missing at the moment. So this will be happening. So if you deliver something, then if you just talk about that delivery to a company or to a people, so then without certification you will just think over, if we have contributed to a OpenStack and the OpenStack is being using that technology, that is actually the expert level, I would say. So this will be delivered through this course within this 35 hours.
So who is going to be the
Yeah, thank you.
Yeah.
Go ahead.
So I'm sorry. So who is going to be the target audience? Just to know little background, who all can attend this, and to whom this course will be more beneficial?
Yeah. For actually, if you have aim to be an expert at some technology, so if you want to work for some company, that is different. And if I want to be a technical expert actually at a particular domain, so then you just think over which domain is basically upcoming and which is actually highly required to the world. So the answer is cloud computing. So cloud, which is very essential at the moment, and if you see it 5 years down the line, so there'll be all the applications, or every application, and whatever thing you required, it all will be from the cloud. So you will not have a PC at home. You will have only a thin client where your PC will be at the cloud. So you just go to the cloud, and actually Google had introduced it. It is called Google Chrome OS. So Chromebook actually. So it will all be like that. So this is actually a very booming technology. If you are expert today, you will be an expert till the technology being evolving. It is actually a big evolving technology. So if you have some and so that if you have a desired aim to be an expert, so if you are an expert, then you are being highly required by a number of organizations. So that is actually the main agenda. We don't want to focus on the end result, which is I just need to get into this company, earn this much. So this is actually the end result. Just don't go into the end result. That's just focus on your aim, then your end result will come back to you actually. That will ping you up, and you can achieve that. So that is where. And so over here, what you can do, you can I would say this session is actually a learning for OpenStack. So in the next session will be through this after enrollment, and next session it will not be an introduction. I would say this is an introduction. The next part, I'll just concentrate on one service, then I'll just get into the API, how the core being worked. So all this working part will be done maybe within 10 hours, and then the next 25 hours will be like we just need to create our own, and then we just need to deliver our thing to the OpenStack. So it should be to that level. So it's not like I just get into that, I just completed a certificate, so where I can, and then you cannot go for an end result. So just aim for to be an OpenStack expert, then you will be an expert over there, and you will get your end result shortly.
Yeah, that's very well said, Swami, actually.
Yeah.
So is this course going to be a full time, or is it a part time, or how that is tuned
timings we haven't decided. See Ganesh, timings and other stuff, I will get in touch with every one of you. We will drop an email with the timings and everything. We will finalize with the trainer as well. However, there is a little scope for participants to give their the timing preference too. So once you give the timing preference, and it also depends on the trainer's availability, we will come to one preferable timing, and hopefully most of them would like it. So that is a plan right now. And we will be starting the batch soon. So we will once the demo is done, we will drop an email with all the information once we discuss with the trainer, and we will get in touch with you guys as well. Like if anyone is interested, it's better you give us your mobile numbers. The reason is we don't market you guys, or we don't use that for any advertisements. All we do is we try to contact you guys, and then we try to find out your preferable timings. And if we have that in place, then we can discuss better with the trainer, and we will come up with preferable timings for everyone. So that is the basic plan that we have right now.
So I'm sorry to ask this question. I don't know if this is the right way to ask. So this is about the trainer. Is it trainer is going to be he is from the core OpenStack who is really working on OpenStack, or how is it? Just to know a little background on the trainer.
Yeah. That's a good question actually. So Swami, just give an introduction of your expertise and everything, so they know that you're actually working on OpenStack. And the other thing I want to add is the trainer who's taking the demo will be the trainer who will be doing the course. It's not like we put the best trainer in the demo to attract participants, and after that you see a different trainer. So I just want to give the confirmation right straight away. So Swami, do you mind giving your introduction to the participants?
Yeah, okay. So yeah, I'm actually basically from a very high network background. So I would say like I'm a budding network expert, and we just focused on, and then we just worked on with layer 2, layer 3 networking. Which is all like data communications and carrier Ethernet, so things like that. And then I just moved into cloud computing, which I said before, it is a very emerging technology, and if you don't have your feet on that, then you will be put outside the box. So so that we just get into the cloud, and we just started up with cloud monitoring. So and then cloud monitoring. So and then so using that monitoring knowledge, we got to know how the cloud setup is, and then we started up how to create that cloud. So we know how this cloud is, and how to create that cloud. So then we get into the open source platform, and as we get into this open source, then OpenStack also started to emerge as a giant expert in the provisioning system. So we just started up with OpenStack. I'm just working for a company which is actually do some more very high level researches, and then design, and then develop a solution, and then develop a solution, test it at data center area, and then deliver that solution to the cloud providers, so cloud service provider, CSP. So that is what we are into, and we are also focusing on comparing all the technologies, and like OpenStack and AWS did. So it actually updates their technology knowledge with upcoming technologies, and then update everything, and they use their best. And if they find technology being missing at OpenStack, then we actually started to focus on the gaps of the OpenStack when comparing with the other providers. Then we started to have a communication set between us and the OpenStack, and we started our own blogging with actually to the portal of the OpenStack. This is how we entered, and we have some set of communication with the experts at the Neutron, and we are actually have some level of not more with the coding part, but actually with the architecting. So we call it as a technical architect. I'm a technical architect. So technical architect was working for core for my company to provide a solution to the cloud service provider, and as a part with the OpenStack to enhance the metadata, which is actually an internal component in the Neutron. So we are actually working on the metadata, so to have our contribution to the open source. So this is how we stand with open source and with cloud service providing. This is actually my background, and what is the future towards this is like we just need since the technology is very being new, and so that we don't find much number of engineers and the expertise at this cloud professionals. So we can see like programming professional is much higher. It's a huge people over there at there, and they will have a high level of competition at this level. But actually, when you need a innovative path, you just get into this cloud, and we started to make like we just need to bring in some more expert on the open source and on the cloud professional, so that we give our contribution to the open source. So this is how when you contribute to the open source, and then you just gain through open source, and then you just gain your technology expertise, and other end result will fall in place. So this is actually the plan for this training as well. My plan towards this technology.
Hello, this is Murali. I just want.
Thank you, Swami. So I would like to wrap it. Yeah, thanks, Swami. I would like to wrap it up here. I know it's weekend time, guys. I don't want to waste your time on this unless you have any other questions. Just want to give a brief intro on Kathy Technologies. Like we, just to answer Ganesh's question as well. Sorry, guys. Just to answer Ganesh's question as well, we make sure that we drill down our trainers, and we make sure the right trainer with the right knowledge is on board. Only then, once we have the confidence that the trainer is going to take training with the participants, and considering the knowledge and everything that Swami had, he was one of the best trainers in OpenStack that we could drill down to. And the other thing I wanted to add is we have been doing trainings on many technologies like Oracle apps, mobile applications, and also on Big Data Hadoop and the other technologies. We have few more companies in Canada and US. We do consulting in Canada and US as well. And we have done few mobile projects under a company called FlexGrow Solutions. So we are Oracle Gold partners as well with this company. So we have servers set up in Canada, and if the trainers need the servers access for any reason, then yes, we are even ready to provide the servers access. Right now we have Oracle applications installed, and people access who get trained in Oracle applications access to servers. So the other point I wanted to add is, if anyone have any other questions, as you can see this slide that the trainer has shared, you can reach us on the email address that you see there, or you can go to our website and you can contact us at 647-771-5067. You can, I repeat, it's 647-771-5067. You can contact us for any other further questions, not just for course enrollment, but any other questions that you have. Any suggestions, recommendations are also welcome. So you can contact us anytime. As long, and Swami, if you have anything to add, you can go ahead. Otherwise, we can wrap it up here.
Yeah, I'm done with that.
Okay, thank you, Swami.
So I just wanted to ask about I'm sorry. I just wanted to ask about the infrastructure point of view for training. Can we get some brief about this infrastructure you have for
Yes, I believe Swami already answered this about the lab sessions that I asked him. He said that if we have the laptops with the configuration, I believe we should be able to do the lab sessions. Correct me if I'm wrong, Swami.
Yeah, it's right. So it is like we'll get the best. So I just required some 3 host PC, and which will be with a decent configuration will do. So we are going to have a micro level understanding of the OpenStack, and then through accessing all the I can I can actually show some of the data center how they are actually having this OpenStack being installed and those things and all. That will be at the end of this course. And so through that, we cannot provide actually it is not possible to provide a data center infrastructure for our learning purpose. So we just need to learn at the micro level and think about at the big picture, and I'll show you a big picture, then you get used to the big picture, and that is how it goes actually.
Just a question from Murali.
Yeah.
Go
ahead.
We have Python scripting. I mean, we are using many Python scripts in many services. Do we need to learn that also as part of course? Python.
Yeah. So I would say like OpenStack is full of with Python. So you just need to have a high level or actually a beginner level understanding with Python. So I would say like all programmings are one and the same. So only just we need to get only the logic, and if you find the logic, and then if you want to develop into that much more, then you just need to have a Python training. But think like it is not part of this OpenStack training, but it is actually a technology training, and a Python level training will be like I can explain how actually the total programming API being communicated, and how this API topology being there and things like that. And code level understanding will be like it will be with the overview of it and not in detail. So it will be like a Python programming, or if I do it like that way, then it will be a Python programming than with respect to the OpenStack. So what is being required for the OpenStack using Python will surely be delivered from this course.
Okay.
Any other questions, guys? All right, then. Thanks a lot, everyone, for taking your time during the weekend. Sorry, who's this? Sorry, we didn't get it.
Hi, this is Ganesh. I'm sorry. The one last question. So, what background do you expect for the audience?
If you understand this OpenStack, the demo, then you are well set and you can join. If you understand from this at least a 20 or 30%, that is required. That's all.
People who are not talking, I would recommend them to be on mute so that. Sorry, I had to put everyone on mute. I don't know. So there was a lot of noise coming. If you have any other questions, you can just use the question bar. Otherwise, guys, if you have any other questions, you can use the chat window. As I said before, during the actual classes, we won't be putting you on mute like the demo, because in the classes you will have to definitely put yourself on mute so that there is no noise coming from your side. And then when the trainer keeps on, like when you have any other questions, you can stop the trainer during this course and you can ask him there and then itself. Alright, then I believe we were done with the demo. Don't worry, if you still have any other questions, as I said, you can definitely drop us an email, or you can call us on our on our number, which is in the website. It's 647-771-5067. Give us a call. We can again discuss further if you have any other questions. And then, as I said, we will drop you an email with all the timings and everything that we are going to have for this actual classes. I really appreciate Swami for taking his time during the demo and spending so much of time in the demo. Actually, it was a very good demo. I really want to thank Swami and all the participants who used weekend time to join to this demo. Thanks a lot, guys, and we're hoping to see you during the actual classes. Thank you.
Thank you. Thank you for providing such a good platform.
Thank you.
Srikant.